So we record all of the sessions and then we put them in our YouTube channel. So if you want, you can have a look at our past sessions following the link below. And we also have our LinkedIn group page. So this is where we put all our updates about upcoming sessions, and also it's a place for you to ask any Dynamo questions or programming questions if you have any. So feel free to join the group. And today our host is Jaime, who's presenting on advanced Dynamo programming with a selection of Dynamo scripts. Jaime will present the wide range of applications the Dynamo has within Revit and bring real examples of advanced Dynamo scripts carried out where he works at Nonica. Jaime got his master in architecture in Spain in 2017, and from 2017 to 2020, he combined his job as architect with advanced visual scripting and programming. And in 2020, he launched Nonica with Blanca. And Nonica is an add-in that simplifies the access and deployment of Dynamo automation scripts. And since 2021, he's an Autodesk authorized developer and develops Dynamo scripts and custom add-ins available in the Autodesk App Store. So without further ado, we'll leave this to you, Jaime.
Okay. Thank you very much, Monica, for the introduction. I'm gonna see how to share my screen here. Yeah. You see my screen and hear me well?
Yep.
So yeah, thank you very much, Monica, for the introduction. I'm very glad to be here with you today and to be able to share with you some of the works and scripts that we have been working on. So yeah, first of all, yeah, we work at Nonica. We are established in Netherlands since November 2020. We are specialized in integrating and deploying Dynamo script at a scale within companies, and we simplify the setup process and make that Dynamo scripts accessible for the Revit standard users. So basically, the structure of the presentation we're going to follow today, we're going to start with application and packages. Then we're going to dive into 3 sample scripts. Finally, we're going to finish with an integration of the scripts as Revit button. So please feel free to interrupt me at any time. I may go a little fast. So if you have any doubt or any comment about any part of the presentation, please feel free to turn your camera on and maybe raise your hand in some way. And I will be glad to try to help you. So we're going to be working with the following software. We're going to use Revit 2022, Dynamo 212, and Nonikatapro 3.1. So also the data set we're going to use today is available for you to download. So you can use like the QR code or also the link for getting the Revit models, the Dynamo scripts, and all the information we're going to be using today. So first, application and packages. We have selected 6 main applications for Dynamo. However, this selection is not exclusive, so there are far more than our selection, but this is like our main focus and what we think is their main use. So then we have brought a few Dynamo packages that are linked to those applications, and then examples of those applications. Some of them we're going to review them today, those in Python. So first, parametric and generative design. We're gonna, well, we usually use Dynamo native nodes, which there's like a wide range that come with Dynamo by default. But also it is quite useful to use well, the code block itself and sometimes some Python snippets that you can find on internet if you wanna like create some standard shapes like thumbs or catenary or something like that. Most of those snippets and small pieces of code are available on internet. So for that application, we're gonna review today the structure of Museum of Arts and Science in Valencia by Santiago Calatrava. And then for design and automation, well, we usually use this Genius, Lossy, and Springs. These are huge packages. Well, it is not only for this application. Obviously, they have like many nodes for different applications, but we found them very useful for working with tags, with annotation, but also to automate dimensions. For that, we have brought also some videos of those examples that we won't be able to review today. So this presentation is already available in the dataset that I said before. So you can use that to click on the videos and watch them later. So for data management, we're gonna, well, what we mean with data management, we usually work with Excel. So for that, Bumblebee is a must-have. Bumblebee allows you to set visual styling, but also to work with conditional formatting, for example, and some other custom nodes that are quite useful to work with Excel. However, we also recommend, we also use many times Excel templates, which helps you to simplify your scripts and keep them more clean rather than having so many nodes around. So for model inspection, BMorph nodes is probably one of the packages to underline, which has like several nodes. For example, the intersection node. There are a few nodes that detect intersection between geometries and elements, and those we're gonna have a look today in the class detection example that we do. Then further on, we have structural analysis. We have structural analysis for Dynamo, which is really nice for working with Autodesk Robot to interact and bring your model from and in to Autodesk Robot. But also, I think, yeah, there is another one for SAP, if there is any structural analysis in here, that is called Dynamo SAP, I think, that is also quite nice for that purpose. And then we bring one of the Autodesk University classes by Kim and Bad. And then for sustainability analysis, you must have heard of it. It's Ladybug, which is quite nice for setting some paths and also to study, for example, the number of hours that sunlight hits a facade or other sustainability analysis. So the example we brought for sustainability analysis is made by Karen Graham. It is a YouTube video that basically explains quite well how to do this type of analysis in that facade capability. So moving forward, yeah. So this is the first example we bring today. It's a parametric structure in Valencia, as I was saying, by Santiago, by Calatrava. This is in the Museum of Arts and Science. And we're going to be working with the following variable. Let me move this. Yeah, it's already started. So we are going to define the arc span. So also we're going to use the archive. These are going to be the parameters and the constraints that define our parametric model, but also interact with the offset height. As you can see, like this middle arc is a little bit higher than the ground. So we're going to also set a variable for that. Then the number of ribs in one side, but also the offset height, like the middle arc is higher than the initial arc. So we set an offset height, a variable. and then the number of models that goes into the x-axis, the number of models that we use to populate the structure in that direction. So let me open this script. So yeah, this is basically Dynamo. So yeah, we usually work with these templates that are quite useful for someone that is new to the script. So we set some names, script version, the software we use, instruction, and what actually the script does, and also set some groups and colors to easily identify the groups in the script. So further on into the parameters, first we're gonna have a look how this works very quickly. So for example, the arc span, the first dimension that goes, let me set this first. Also the archive, the interact with, which is pretty much this dimension. Then the offset height of the middle arc, also the offset height of the top arc in here, the number of grids that comes in one side, and the number of additional models.
Jaime, will you be able to share these scripts with people that have joined the Dynamo user group?
Yeah, they are available in the dataset here. So if you have just joined, you can download all the scripts and Revit models in this link or by scanning the QR code. So if you want to follow me, please feel free to go with the files.
Okay, maybe I'll also send an email to all the participants after this, just with links to remind people where they can download everything.
Yeah, do you want me to keep? I think I can do like a quick maybe screenshot
Awesome.
and keep it like here or something like this.
Yeah, okay, you can just send an email afterwards. So you keep the screen free for everyone to see the whole screen.
Okay, yeah.
Yeah. Thank you.
So yeah, the number of additional models, we're gonna keep this to 0 to explain it with one model, which is gonna probably be easier. So first of all, we're gonna start. It is very important that everything that we define in our script is linked to those parameters. So when we change them, the whole model changes with them. So we're gonna start by setting points and curves. So first of all, we start with the origin point in here, and then we start with two more points. This point, which I like y coordinate is coming from the arc span, and then we take this point, which is coming from the middle of the arc span, but also from the archive. So using these 3 points, we create a curve. So we create this curve, basically. So with that curve, we're gonna go for creating the curve in the middle arc. So for that, we again create 3 points. We create the point at the very beginning, again with the coordinates based on the parameters, and also the point at the end using the offset height, as well. Again, the point at the top that we use for the set coordinate, in this case, the sum of the archive plus the offset height to get this top point. So using that, we create the curve, the middle curve. Then when we have our 2 curves, we're gonna go into the next step. As you can see, the section of this arc is variable. So it's not the same at the bottom, but at the top, than again at the very beginning. So we're gonna define some more input variables for this purpose. So we're gonna define a range that we'll be using for working with the curve, but also the height section in the base, the height section at the top, the width section that is going to be constant in all the arc, and also the middle square section, which is pretty much a constant through all the arc in the middle arc. So with those values, we're going to create the variable section of the initial arc, this one over here. So for that, we're gonna, with the range we created, we're gonna work with what is called a parameter. This type of node, basically, it allows you to work with a curve in a kind of like percentage base. So if you input the curve, and then the parameter, it can be a value from 0 to 1. So if you set the value 0, you get the point at the very beginning. You get, if you set 0.5, you get the top, and 1, you get the end of the curve. So with the range, we are going to divide our curve in 21 points because we're going to count every 0.05. So we're going to count 21 points, counting the end of the curve as well. And those points in the curve, we're going to use them to get the coordinate set, the height of the point itself. And then we're going to divide that by the arc height to get like a relation based on the arc height. And with that arc height, what we're going to do is we're going to multiply that by the difference in the section. So in this case, the section at the bottom is 0.4 and at the top 0.15. So we're going to get 0.25 and multiply that by all the relative coordinates we used before. And then based on the initial section, we get the height. So basically the height is going to go from 0.4 at the bottom, at the point 10, that is the top 0.15. This is the height of the section again. And we're going to use that to create rectangles. But for creating rectangles, we need planes because we need the rectangle to be placed in normal planes. So we're going to use this node to create planes, again with the range that we defined earlier. So these planes, let me show you. Yeah, these are the planes that we create. So this creates normal planes to the curve in the parameters we set. In this case, like the points we set earlier. Then based on these planes, we're going to create the rectangles. As you can see here, a small black mark. Those are the rectangles. And then those rectangles are going to be the input to this node, which requires the cross section of all the rectangles, and then the guided curve, which is the initial curve we use. And then we get the arc based on that. So let me hide this. Yeah. So now we already got our section variable, our variable section, sorry, and then we're gonna use, we're gonna get the middle arc in place. So for that, we're gonna use the curve planar parameter, but now we only need one. So we're gonna use the point 0 to create a plane at the bottom, at the beginning, sorry, which is right here. And then we create a rectangle on that plane, again, using the variable here. And based on that, we just surface following the path of the curve. We create a surface by slip. Now we got our two arcs, and we're gonna go for the last one. The last one is tricky because when we create several models in this direction, if we create this one and it goes with the models, we're gonna have duplicated geometry in all the models we create. So what we are gonna do is we're gonna create what we call a closing arc. So the geometry that is gonna be repeated in the axis is gonna be everything that we see, but not the blue arc. And then at the end, we're gonna just place the closing arc so we don't have duplicated geometry. So for that, we are basically just gonna use the variables we have. We're gonna use the interarc width and then also the number of models to get basically the value we want to input into this node. This node is quite useful for working with modular designs because it allows you to translate a geometry, like literally just saying what distance do you want in what axis. So we use the initial variable section arc to translate, literally make a duplicate, let's say, of that geometry with the direction we get from the variable. Nice. So we already got our 3 arcs. So we're gonna now dive into the roots, right? So for that, as you can see in the initial design, the ribs itself do not start at the bottom of the arc. They start a little bit higher. So for that, we're gonna trim our curve. We're gonna get this curve, and we're gonna trim it 5% at the beginning and a 5% at the end. And then we're gonna use points at equal segment length to literally split our curve into the number of divisions that we set in this variable, in the number of ribs. So we split the curve with the number of ribs that are coming from our variable. So we split both curves. We split the initial arc, but also the middle arc. And then with all those points that we get, we are just gonna use cylinder by points radius. It will allow us to create cylinders by start and end point. And then we set a radius for creating the cylinder. So now that we have the ribs created, we are just gonna do something very simple to mirror our geometry. We're gonna create a plane based on the 3 points that we have in the middle arc. So with these 3 points, we create a plane, and then we mirror the geometry of the ribs that we created in this node. Nice. So we already got, let's say, our first model. So what we need to do is how to basically multiply this model n times in the x-axis. So for that, we're gonna use geometry translate again, and we're gonna first gather all the geometry we created, except for the closing arc, and we're gonna input that into the node itself. So we're gonna set the x-axis as the direction in which we want to translate our geometry, and then we're gonna create a range that is gonna start. Well, I set this to 0 because I wanted to explain this exercise with one model. But actually, if you have that set to 0, you're gonna have duplicated geometry into the initial model. So if we set this to 2, and we come back here, this will be 1, because otherwise the first model will be repeated. So with this range that we create, it literally numbers from the start until the end, and the end is based on the number of additional models. So that is multiplied then by the interact with one of the variables, one of the parameters we have here again, which is, this one, define the distance from here to here. And then those values, we're gonna pass them into geometry translate. So they're gonna create these 2 additional models. And then finally, we got all our geometry. So we just need this to bring to be in Revit. So for that, we're gonna, well, so for that, we're gonna just use import geometry to Revit. So we're gonna get all the geometry and flatten the list, and then use this node import instance to by geometries to literally just bring all the geometries to Revit. It is quite important when you bring this type of geometries to Revit to check the project unit you have in your model to check as well if those units are the units used in your script. So in this case, we set the project units to meters. Yeah, we set the project units to meter, and also the variables are set in meters. And also one thing to underline in here is that this node is very close to yeah, it's very close to this one, but it is not the same. So if you find like your geometry is upside down when you are doing parametric design, it may be coming from this node because this node has some type of batch processor or something that in some way can sometimes understand your geometry in the wrong way. So we recommend to use this one despite it's not as effective as this one. So yeah, this is pretty much the parametric design script we wanted to explain today. And then we're gonna go into the next example.
I can ask you a question.
Yeah, for sure.
I think it came up in a previous presentation as well. But if you have to update, some of the parameters and you go and rerun the script, do you need to delete the geometry in Revit and rerun the script, or if you rerun the script, it will update the current geometry that you've already got in Revit?
You mean if after I created if after I run the script?
Again, with different inputs, yeah.
Yeah, I mean, the issue is, you see it here, is like, because the Revit geometry is different to the Dynamo geometry, it creates it again. However, if the geometry is the same, sorry, yeah, this is the all instance. If the geometry in the Revit model and in Dynamo model is the same, it will be kept. But if we change, for example, the number of models of some variables, we may need to delete the geometry in Revit and then bring it again from Dynamo.
Thank you.
Okay, so next script. We're gonna be using this model. I guess most of you know about this model. So yeah, basically, let me open Dynamo. We're going to be using this model for creating a column report. So the column report we're gonna create is going to be based on some of the parameters of the columns. So in this case, for example, we have like concrete column that has like certain instance parameters, like for example the mark, which defines the unique identifier of the column, but also the level of the column. And then we're going to be using also type parameters. For example, the concrete columns has dimensions and also, basically the dimension, which is the radius of the diameter, sorry, of the column. Also, on the other hand, we're going to be gathering information from the steel columns. We're going to get again the level of the column, but also the material and the section area of the column. So in order to work with that, we have created an Excel template that we're going to be using to input the information from Dynamo. So something that maybe not many people know about when you create Excel templates for Dynamo is that, well, apart from like simplifying your scripts from packages and all that, just allows you to basically work with nodes by default in Dynamo, but also it allows you to set formatting. So for the formatting, we could actually set the formatting in the cells that we're gonna input the information. For example, this column, sorry, we're gonna bring unique marks from the columns. So we're gonna set bolds and we're gonna set this font as well as this size. But for example, in here, we're gonna bring project information and we're gonna set the the font to white. Also, we're gonna center the text, so you can actually like work with the template before the data comes in. Yeah. So basically, we are prepared to go into the script. So yeah, this is basically our script. Yeah, maybe first of all, the functionalities, giving the structural column category is going to store reference, material, level, dimension, and shape into a copy of our Excel template. Like sometimes working with copy file or writing to Excel can bring issue to use automatic mode, but also it can require refreshing. Like once you run it once, it could require you to like unplug and plug it again in order to work it well. Then yeah, we're gonna run the script so you can actually see what it does. So yeah, we got our excellent here. So we have brought all the information we were discussing before. So we have brought the project information into this part, but also all the reference materials, levels, dimensions, and shape of the columns, depending on, like, of course, if it's a steel or concrete, all the information comes organized. So we're gonna go into the script. This is a much more simpler script than the previous. So we're gonna first just define the paths. We're gonna define where our template is, and we're gonna define where we want our new file to come in. Then we're gonna make a copy of our Excel template because we don't want to destroy or damage our template. We want a copy to work with. In parallel, we're gonna work with categories. We're gonna input the structural column category and get all the elements in the category and sort them by mark. We want all the list of elements to be organized by mark. And then we're gonna use that sorted list for the coming processes. So first of all, we're gonna start with getting the instance parameters, the mark from the sorted list. But also we're gonna get some structural material and level parameters. So in this case, you get reference elements. So when you get this type of elements and you want to actually get the name, you need to like plug another node like this and call the property name. Then we're gonna get type parameters. So for the type parameters, you need to first you got the elements, so you need to convert them to element type and use them for getting the parameter. We use 3 nodes because we want them. We want 3 lists to be separated, so we can work with them separately. So, for example, the B parameter is coming from the concrete column, so we have some empty values in the steel column, but also the section area, for example, is coming from the steel column, so we have empty values in the concrete columns. So we need to merge both lists. So for that, we use the if node, and then we use an equal statement to merge both lists. So we got our list merged with no empty values. Then for the project information, we're gonna use this very useful node by Clockwork that literally brings organization name, description, and all this information about the project. We're just gonna be using these 4 and get them into a list creator. Now that we have all our data, we're gonna write them into Excel. But because we have 2 places to write information in, we have the project information at the top in the header, but also the data, we're gonna use 2 sets to write the information. So for the project information, we get the data and we set the star row and column to write the information in there. And then for let's say the main data set that we got, so we are gonna use a list join to join all the lists of the parameters, but we need to format that before we input them. Otherwise, with this format, we will get like very long rows. So the format for inputting into Excel will look something like this, organized by list. So each list is going to be a row in the Excel. And then we're going to use that information into the export to Excel. And one thing that I left behind is this pass-through node. This is useful because we want to make sure that before we write all the information in the Excel, we want to make sure that our file, our template has been copied to the right place. So therefore, we set to wait for, so we set this node to wait for this node to bring an output. And then when that node has worked well, we pass the value of the path that we want to write Excel. And this is pretty much the second example I have.
Jaime, there's just a couple of questions in the chat.
Yep.
I think the first two refer to the first script, and then there's one about this one. Do you want to maybe just answer them?
Yeah, let me see if I see the chat. Yeah. Only see the question now. We'll wait for some. Okay, for working with Revit families, this can sometimes be tricky because family have like parameters that are sometimes difficult to access from Dynamo. So there are certain parameters that are, as I said, like difficult to access. So I think BMOS have some probably have some parameters for families. I'm not quite sure right now on the top of my head. But I mean, if you send me an email, I will be glad to have a look and reply to you with a little bit more time. And also, any other question? Can you assign? It's possible to import instance and assign it to a Revit category. I don't really understand the question. To import the instance geometry.
I think this is for the first script,
Yeah,
so the one
okay.
that you did before. Yeah.
Can you add coordinates and level data as well? Yeah, of course. You can get coordinates for the geometry and bring, well, level data is actually in here. Level data is coming from this code block. We get the level in here, and we use name to get the level names of the columns. So you can see them in here. Yeah, I think that's all right. So yeah, let's dive into the next example. So for that, we're going to use this model. So basically, for class detection, which is this example about, in the recent version of Revit, there are already some tools that deal with this. I think, yes, right here. So this actually allows you to check interference by categories, but we wanted to customize our way of working with classes. We wanted to store the classes in as 3D views and mark the elements to see them in a, like, let's say, like easy way. So for that, we created the following script. So yeah, probably it's better if I first run it. So like basically this is given two Revit categories and colors creates isolated 3D views of classing elements color. So if we input here whatever two categories, it's gonna create 3D views with the elements that are clashing color, but it's gonna also create bounding boxes of those elements so we can easily locate them. So for example, if we have like a huge building with 6 floors and sometimes it's difficult to find that element, we set this bounding box so you can actually like work with it and see where the element is and solve the class itself. So basically, the shape of the intersection is gonna shape our bounding box. So in this case, the intersection is all along this wall. So that's why we have this object. That's why we have this shape, basically. Yeah. So going back to Dynamo, so if we set any other category, for example, that there is no class, for example, word, it's gonna pop up a message that let us know that no class has been detected. But again, if we run it again, we're gonna get new views following the numbering, the numbering that we have before. So this allows you like to actually manage and send the classes that you have detected. So for that, we're gonna start with the two categories, and we're gonna get all the elements in those categories. All those elements, we are gonna use them to create lists. But before passing them into the intersection nodes, we're gonna check if any of the list is empty. Because if the list is empty, this node is gonna bring up a warning. So to avoid that warning, we create these two if statements that allows us to pass one element. So when this node detected an intersection of one element with the element itself, it's not gonna bring up anything. So it only detects other elements with, let's say, the first element. So with that way, we avoid the warning of that in a certain situation. So once we got our, let's say, intersection, is the format that we output. Basically, this wall is going to class with these two floors. This wall is going to class with these two, and again, this one with these two. So we're going to have to work with that data. So first of all, we're going to check if there's any view that start with class. So if there's no view, we basically bring all the elements in the category, including the list, because sometimes bring some null and empty values getting view category. Also, we check that no view has a start with class, and then we have two paths. This is something that I mean we usually use in our scripts. It's some kind of like trick that you can use as well for other scripts. So it is a way to setting two paths. So what we do is we set two if statements and a dummy value. The dummy value is only gonna work if the top part, the top path is passed. So if we have no class view in our model, this path is gonna go. And with the dummy value, we avoid all these nodes to bring up warnings. However, if we have like the path to working and it's the path working, we're gonna pass the value that we want from the previous process, and we're gonna get the number that we want for naming the views. In this case, 6. So 6 is the number that is, yeah, 6, because the initial run we did, there was 6 class detected. So this detected like 6 and started the naming of the following views from 6. And then from there, we're going to name the views. So this basically just bring the categories and use these code blocks to create the name of the views based on the categories and the number that follows the views. So from there, we're going to go into creating the 3D view. But for creating the 3D views, we're going to use this node that use the view names and also the bounding box, which is the section box that we have in here. So this section box is used for creating the 3D view itself. So that bounding box, we're going to create it here. So we bring the element that clashes. So these two nodes is again for avoiding the warning in the case there is no clashing. Then we're going to detect the intersection of both bounding boxes. And then with the bounding box that, let's say, gets the intersection, we're going to scale it to get it a little bit bigger and zoom it out in the intersection so we can see it a little bit bigger. So from there, we create our 3D views, and if no 3D views are created, this list will be empty, and that will mean that no class is detected, and this custom node will bring up the message. If views are created, like the level of detail will be set to find, and also like the visual start to save it, not to hide the line, sorry. And then we're gonna see how to color the classing elements. So we're gonna use these color selection nodes. So we're gonna input those values into these big nodes. The big nodes are basically for creating graphic settings. This only creates the graphic settings of the elements. So we input the colors into the graphic settings, but also the patterns we want to use with that color. And those are used to override the element view in that view. So we input the view that we created, the elements that we want to color, and the graphic settings that literally is gonna color to our elements to this color. So yep, this is pretty much also the class detection script. Let me check if there's any question. Yeah, here's one note by the package we were mentioning before. Thanks, Fred. Then let's keep it going. Let me close this if there's no more questions. And then we're gonna do a short review on how to integrate those scripts into our Revit toolbar. So let me select one 3D view, for example, this one. So basically, one of the add-ins that we have published is Nonikatapro. I'm not going to go into the details of the differences in the different versions, but basically we have like a free version that has limited features and allows you to work with 12 bottoms, and then like a pro version that has like much more features like package detector, input detector, and also is meant for deployment, so you can serve the toolbar with other computers. So once we install Nonikatapro, is the 12 bottoms we get. They're empty bottoms. We have this first bottom. This first bottom is a profile selector. So each profile has 12 bottoms that we can use to restore all our Dynamo scripts. So in total, we have like 36 potential bottoms that we can use with our scripts. If we want to organize, for example, for modeling, auditing, and I don't know, like whatever is meant for. Then we're gonna create one bottom, for example. So for just setting a bottom is quite simple. There's a drop down that you just click and you have the information for setting that bottom. For example, we can just set up a script. We're gonna select the class detection script, and then Nonikatap detects that there's script already, and set the name of the script by default, but we can also change it. We're gonna first set an icon. Yeah, we include set of icons that can be used for your bottoms, but you can also select any other picture for your bottom, and it will be converted into the format required. So in this case, we selected our icon. And then you can also set up details. For example, you can set up the name you want for the button if you want another name, but also the explanation. For example, we can set the text classes into Revit categories. We can also add, for example, break lines if we want, by just adding break line, and then we can add, for example, further details. For example, and then our bottom will display that information that we set. Once we got all our bottom set, we can set other profiles, but we can also go to settings. Settings literally displays all the bottoms we have set, and allows us to customize the name of the profile to whatever we want. But also other features that are quite useful are import, connect, export, and refresh all. Refresh all is very useful when you're working with your scripts. So if you wanna like update all your scripts at once, you just click refresh all, and it will be refreshed with the current version. However, like scripts need to be into the same location and with the same name.
We just lost you. You're on mute, Jaime.
You know?
Cool.
Do you hear me now?
Yep.
Do you see my screen still, or?
Yeah, I can see. Yeah, we can still see the screen. We just went on mute.
Okay. Yes, a final remark then is that we can refresh our bottoms, but we can also export them to share the bottoms with other computers. And what is nice is that actually all the packages are detected when we export our toolbar, and when we import them, they are automatically set up in the importing computer. So, for example, we can import one toolbar from around here. Yeah, this toolbar was created by Gavin Graham. So yeah, automatically brings all the bottoms to another computer with all the packages, so we can just have them and share them with our colleagues and everyone. This is pretty much the end of the presentation. I hope it was useful for everyone. Now, if you have any question, please let me know. I will be glad to try to help you in any way. But also, if you want to send me an email or contact me by any social network, I will be glad to help you or to try to help you at least.
Has anybody got any questions? Actually, well, I'll start. I have a question about your plugin. How can you use it to deploy? Like, if you work for a big organization, is it something that you can use to deploy the scripts to?
Yeah, actually, I didn't get into that, but if you go into Revit, there is one feature that is called Connect. This feature allows you to connect target computers to a file. So you can actually, by exporting your toolbar into that connected file, you can change at once in 2 clicks hundreds of computer toolbars at once. So you don't need to import and export all the time. So you connect this to a .Nonica file, and then from the admin, let's say like the master computer, you export your toolbar on top of the connected file using the target computers, and then all the toolbars are automatically updated.
And where are the packages? Sorry, this is quite interesting because there's actually, we had Mustafa doing a presentation a while back, and he's got a similar tool that's called Orchestra. So
Yeah.
I'm just curious about the differences between the two. Where are the packages? So how are the packages deployed to people's machines as well? Where are we saved?
Yeah. When you export, for example, in this computer, I have like all the packages that we saw before. So when I export my toolbar, it literally scans all the scripts I am exporting, and all those packages in those scripts are included into the process. So I don't actually need to do anything to bring the packages to other computers. So I just export and import in the target computer. If I want to like set updates from a remote machine, I will need to connect them. But again, connect, it also updates the packages.
Cool. Oh, that's great. Thank you.
So yeah, we basically try to make it as simple as possible. So all our bottoms are like very, very simple to customize. We don't want you to run into complicated stuff. So we want to make life easier. That's our goal.
Yeah, and I found that, yeah, working with other people that are not too keen on opening Dynamo, this is way more user-friendly to have a plugin that allows you to do that even better in the Dynamo player.
Yeah, yeah. And what is very useful also is that you can even like use Revit shortcuts to run your script. You can also set, for example, a shortcut and run your script from just a bottom.
I think there's a couple of questions again in the chat.
It's a common representation, Jaime. We use the Nonica product at Chicago Polytechnic was very well helped us streamline models to the beam models, lots of great practice and methods. I'm very glad to hear this play. So we are very glad to hear. Actually, like for students, we give students and universities free licenses. So if you're interested in a free license of the Pro version, we will be glad to provide it with you. It is available in our website, all the instructions that you need to follow.
Then there's one from Richard. Can we have a PDF copy of your presentation?
Yep.
Yeah, I think, yeah, I'm going to get in touch with you and then I'll share with everyone. I'll send everyone an email with all of the materials. There was another one. Can you bind the Dynamo and Revit models like dynamic model? Not too sure. Can you bind? Not 100% sure what that means.
Yeah, actually.
Hi, James. Hello.
Hello.
Yep.
Hey, do you
Hello.
want to explain? Yeah. Hi.
Yes. So what I mean to say is from your Dynamo model, and then you like let's say generate that one to a Revit model, and then once you done your work, you save it and then open it again, and then once you run your script, does it update the Dynamo to Revit model, or does it gonna generate a new element again and then erase the old one and then yeah, just basically retain the new one. So it's like a delete and replace, or is it gonna be updates the model?
No, it's gonna actually create a new instance of that geometry. So if you close your model and then run the Dynamo script again, you're gonna have two instances of the geometry. So it will probably be better if you like delete it and work with the parameters if you want to make some changes or.
Yeah,
Okay,
it's actually it actually depends because the method that you use, Amy, the instance they create, it's like there's nothing that you can. It's not actual Revit geometry that you can then edit in Revit. It's like
Yeah,
it's
it's like a
yeah,
block.
it's like a block. But if you actually, I think, if you actually model like a beam in Revit and then you rerun the script, then it does create that connection where if you rerun the script, it will update the model geometry in Revit. I don't know if I think there was a
But
presentation. I don't know if you still hear it.
okay, so there's no like a dynamic link between the two models.
I think if you do model actual Revit geometry, actually there's Tatiana. I see that you are connected. I don't know if you're actually listening. I think you can probably answer this one. I'm not sure.
Okay,
Because
so
Tatiana did a presentation. I might ask her because she did a presentation a while back and it was a similar situation. And I remember this question was asked. And if you do model actual Revit geometry, then it does create the link between the Dynamo and the geometry. But it needs to be like you need to model a beam or something else. It doesn't have to use that node. That it just creates a block that you can't edit in Revit.
well,
yes, yeah.
Hello, sorry.
Oh, sorry.
Oh,
but-
Yes, yeah. It's kind of like what do you call this one? Like they got like a direct link. So I mean to say, once you close it down and then open it again, it recalls the element that's been generated before. So yeah, kind of like if it's gonna be a promising if we have like a dynamic link between the two models at the same time. But anyway, I just only wondering what type of category or Revit family is generated once you run the script. Is it a generic, or is it like a direct ship, or it's just a block?
No, it is. I'm not 100% if it's a block or a group, but I'm quite sure that you can actually explode it to get the separated geometries if you want.
Yeah, but it is you can assign it a category, but yeah, you can't edit it.
Okay,
Yeah.
cool. Yeah, thank you very much, James.
No worries.
But-
Thank you very much.
Yeah, sorry, Tatiana. So you try to.
Oh yeah,
Do you
yeah,
want-
no worries.
yeah.
Yeah, I think so pretty much like what Monica was saying. So that's sort of right. So it's, I guess, a lot in how you create geometry, and yeah, if you use what I did in my presentation, like using the proper family, and then you can actually edit parameters, reassign category, and so on. Was that the?
Yeah, it was more about like
right?
if you have to rerun the script, if then the geometry in Revit will be updated, or if you need to delete or recreate the geometry. Because I remember when you did your script, the question came up, and you said that you could the geometry would actually get updated in Revit, but I think because you model actual geometry in Revit, whereas the example that we had today, it was a different node where it just creates a block that you can't edit.
Yeah, so I think so it was that I would actually be editing manipulating the family, which was you would pick up those, is that yeah. So yeah, if you create elements in Revit and then try to your script is essentially updating it or creating new type, creating new families and replacing that. Yeah, so that's like, because essentially just reads that element from Revit. But if your script creating new elements, so there would be ways, like if you can't get the identity data of those elements, you could potentially, it would still be, if it's just like input instance from my experience, what I've been doing, you could like find those elements if once you created them, you have exported their identity data, and then you can pick it up and replace those. But yeah, so that would be the case. Also, like there can be some things that can complicate this process, or like if you create next time a different number of elements and so on.
Yeah, so not as easy.
Yeah, it's not. Yeah, I think it's not as easy. Yeah.
Yeah, cool. Thank you. Oh, that.
Okay.
Any other questions? Otherwise,
there is one question. Yeah, I mean, Nonikatapro is per person. Like the subscription is per person per se. Yeah. So if you have any doubt, I'm gonna leave our contact email in here as well, and you can ask any question about the scripts or like Revit models or whatever about Nonica as well.
that's great. Thanks, Jaime, and that was a great presentation. Thanks for joining our Dynamo user group and sharing your knowledge.
It was a great pleasure to be with you today.
Cool. All right. Thanks, everyone. Enjoy the rest of your day, or good night to Europe.
Good night, everyone.
Yeah. Bye.
Thanks, Monica.
Thank you, guys.
Thank you, guys.